Welcome, students. Today we will start with a new topic, that is kinematics of robots, under which there is one important topic that is known as degree of freedom. So in today's class, we will start with what is degree of freedom, what is the formula to calculate the degrees of freedom, what are the terms associated in the formula, and we will have some examples in which we will find out the degree of freedom for a given mechanism. So let us start with the definition first. What do you mean by the word degree of freedom? So in technical terms, it is defined as the minimum number of the independent coordinates needed to specify the position and the configuration of the system. So this was the technical definition. That is, it is the minimum number of independent coordinates needed to specify the position and configuration of the system. In simple terms, if I say, it can be written as it is number of ways a rigid body can move. So this is a formula for calculating the degree of freedom for a system. It says that degree of freedom is equal to lambda multiplied by n minus j minus 1 plus summation of I1 to j fi. Now let us see what are the terms associated in it. So the first term which we can encounter is lambda, which can be termed as it is a total degree of freedom that can occur. For example, let us refer to the diagram on the right hand side. Here it is seen that 2D coordinate system and one is 3D coordinate system. Now, in this 2D coordinate system, what can happen? A body can either move in x direction, it can either move in y direction, or it can rotate in this plane. So what can I tell is the degree of freedom, the total degree of freedom is of this entire 2D system is 3, because one is the translation is x direction, one is the translation is y direction, and the third one is the rotation about xy plane. Hence, for a 2D system, always lambda will be equal to. Similarly, if I consider the 3D coordinate system, what will happen here? This body can move along x, it can move along y, and it can move along z direction. So these are the three motion possible in the respective axis. Also, this body can rotate in xy plane, it can rotate in yz plane, and it can rotate in xz plane. So the total number of motion possible in this particular 3D coordinate system are 6. 3 translation and 3 rotational. Hence, lambda for 3D coordinate system will always be 6. So I hope that the concept of lambda is being cleared. So for a 2D system, lambda will be equal to 3 as it has 3 motions possible, and for a 3D system, lambda will be 6 and it has 6 motions possible. Now let us go to the second term, which is n. N is termed as the number of links in the system, or in other words, I can say how many number of bodies or objects are there in the system. So we have to just count the number of bodies or objects or links, and that will be your n. Then the third thing is j, where j is termed as number of joints. It is also termed as connections. Now, because it is mechanism, one body will be connected to other body by means of some joints. It may be either a sliding joint, or it may be a rotating joint, or it can be any other joint. Let us say an example here. In this mechanism shown on the right hand side, you can see that particular block, this particular block is translating is in this direction. So I can say that the degree of freedom of this particular block is 1, because it can rotate, it can translate only in one direction. Similarly, if I tell about this particular joint or this particular body, we can see that this particular body can move only, or it can rotate only in this direction. It cannot translate, but it can rotate. Hence, the degree of freedom for this particular joint is also 1, because it is free to move or free to rotate only in one direction. Now, if I consider it to be number of joints, what is a joint? So here you can see that this slider, which is connected with this particular rod, So there is connection between a slider and the rod that is known as a joint. Similarly, this rod is also connected here. So this is also a joint. So wherever there is a connection between two bodies, that is considered to be as joint. Now, the last term, summation of I equal to 1 to j fi, that is sum of degree of freedom for all the joints. So what we have to do is we have to see the number of joints in the system, and for each joint we have to count the degree of freedom. Let us say there are three joints in the system, so we have to see for that particular three joints how many degree of freedom are there, and just we have to sum up. And for you, I will just give you a note that the degree of freedom for a turning joint and a sliding joint is 1. Because for a turning joint, as seen in the diagram on the right hand side, it is allowed to turn only in this particular direction. Hence, the degree of freedom is 1. Similarly, for slider, as it can move only in this particular direction now, the degree of freedom is also 1. So this is, you can remember that for this particular mechanism or for any mechanism of a turning joint, the degree of freedom will be 1, and also for sliding joint it will be 1. So this slide gives you the basic of what is degree of freedom, what are the different terms associated with degree of freedom. Now let us move forward to solve some problems on how to find out degree of freedom for a given mechanism. So the question says like this: determine the degree of freedom for the following mechanism. And this is the question given. We will write the formula. Formula for degree of freedom. Formula to calculate degree of freedom is degree of freedom is equal to lambda into n minus j minus 1 plus summation of I 1 to j fi. As we have discussed earlier, because it is a 2D system, lambda value will be equal to 3. Because there is no 3D, because it is a planar mechanism, the lambda will be equal to 3 because it can move either in x or in y, or it can rotate in xy plane, this entire mechanism. So I will write the value of lambda as 3 because it is a planar system. Next is number of links, that is n, for which I told you in simple terms, links are number of bodies which are attached or number of members which are attached. So let me count the number of bodies which are there in this particular mechanism. So starting with this part, this particular joint, let us say it is number 1, this particular part. Then this part, let us say it is number 2. This particular member is number 3. This particular member is number 4. And this particular member is number 5. So at a glance, we can see 5 members which are there in the link, and one more member is there, and that member is nothing but this one, the ground on which it is attached. So this entire ground is termed as one link. So the total number of links in this particular mechanism are 6. 5 which are seen in the diagram from the observations, the number of members, and one will be the fixed link, that is the ground. So here we have find out the number of links in this particular mechanism is 6. Now the next part is number of joints. Number of joints may be either, normally it can be either a rotating joint or it can be a sliding joint. So if I highlight the joints, let us say this is a joint here. So this is joint number 1. This particular joint is there connecting two members, joint 2. Then this is the joint because it's connecting other two members, 3. Then this is the joint 4. This is joint 5. This is joint 6. And this is joint 7. So there are in all total 7 joints available in this mechanism. So I will write J is equal to 7. Now the last part, summation of I1 to J Fi. So when we have discussed about this part, I told that it is the summation of degree of freedom for each joint. And also I have given you a hint that for a rotating joint, the degree of freedom is 1. And here we can observe that all the joints which I have highlighted in yellow are the rotating joints or the turning joints. And for turning joint, the degree of freedom is 1. So because there are 7 joints, there will be the summation of degree of freedom for all the joints will be 7 because there are 7 different rotating joints. So here I will write summation of Fi I1 to J is 7. Now as we got all the parameters with us, we can substitute the formula DOF is equal to 3 multiplied by 7 minus 6 minus 1 plus 7. This all parameters we have discussed and found out. And on solving this, I will get the answer of the degree of freedom of the entire mechanism is 1. So this completes the solution. So what you have to do is you have to analyze the diagram. You have to count the number of links, number of joints, and just substitute in the formula and get the required answer. Now let us have a discussion on one more problem of this time. So let us say for the other mechanism we have question number 2, determine the degree of freedom for the following mechanism. And this is the mechanism shown. So again, as it is asked to find out degree of freedom, I will first write the formula, and the formula is DOF is equal to lambda n minus j minus 1 plus summation of I1 to j fi. Now, in this, we have already discussed about lambda. Because it is a planar mechanism, lambda will be 3. Then, regarding number of links, for number of links, I give you the hint that it is number of members it is having. So let us count the numbers for this particular mechanism. So this is link number 1 or member number 1. This is member 2. This particular block is member 3. And the ground one, all the grounds will be considered as a link, single link. So this is link number 4. So the total link in this entire mechanism is 4. So I will write n is equal to 4. Now regarding J, I will highlight the joints. Joints means where the two members are connected to each other. So let us analyze that part. So the first connection is between ground and this particular member. So this will be joint 1. Then between member 1 and 2, this is the connection. So this is joint 2. Between member 2 and 3, this is the connection. So this is joint 4. Sorry, joint 3. And this particular slider is a sliding joint because it is this entire thing is connected to this particular part. So this is the sliding joint. So the total number of joints, as you can see, highlighted yellow ones, 1, 2, 3, and this one is 4. So I will write J is equal to 4 here. Now regarding summation of I1 to J Fi, that is degree of freedom of each joint. So as I have told you in the first slide itself, that the degree of freedom for a rotating joint as well as sliding joint is 1. So in this particular case, there are 3 rotating joints and 1 sliding joint. That means total 4 joints. So the degree of freedom for all this collectively will be 4 because there are 4 joints. So I will write summation of I1 to J Fi is equal to 4. Now, as we have got all the parameters here, we will now write the formula and substitute the values of the at the respective places. So I will get DOF is equal to 3 into 4 minus 4 minus 1 plus 4. So finally, I will get the degree of freedom of this entire mechanism as 1. So this completes the solution to the given question. Let us move forward and discuss one more mechanism of such kind. So question number 3 says that again, determine the degree of freedom for the following mechanism. So this is a mechanism given. Again, as per the normal procedure, I will first write the formula, which is DOF is equal to lambda into n minus j minus 1 plus summation of I1 to j fi. Now in this again, because it is a planar mechanism, lambda will be equal to 3. Then regarding number of joints are basically number of links or number of members. So let us just count the same. So here you can see that this is member number 1, this is member 2, this is member number 3, and this is member number 4. And the ground is termed as one link. So this is link number 5 or member number 5. So in all, the total number of links in this particular mechanism are 5. So I will write here n is equal to 5. Now regarding joints means where these two members are connected, by which mechanism. So the number of connections are known as number of joints. So if I highlight the joints here, from this link, ground link to this one link, this is the joint. So this is joint 1. Then between this two links, this is the joint. So this is joint 2. Between these two links, this is joint 3. And between these two links, this is joint So in all, there are total four joints. So I will write J is equal to 4. Now regarding that summation of I1 to J Fi, it is the degree of freedom for each joint. So now there are four turning joints and the degree of freedom for each turning joint is 1. Hence the total number of degree of freedom for all joints will be 4. So here I will write summation of I1 to J Fi is equal to 4. So now as we have got all the parameters, we will just substitute in the given formula like d of is equal to 3 multiplied by 5 minus 4 minus 1 plus 4. Just substituting the value which we have just found out. And finally, on solving this, I will get the degree of freedom as 4. So this completes the solution to the question given to find out degree of freedom of the following mechanism. So we have discussed about three different configurations and how to find out the degree of freedom for the various mechanisms. So hope now you don't have any doubt in this particular topic and you are able to solve any problem on this particular topic, that is finding out degree of freedom for a given mechanism. Thank you.